I need to walk you through something that just unfolded with this interstellar comet, and honestly, it's making a lot of folks uneasy. NASA flagged a fresh shift in the object known as 3II Atlas today, and quietly revised the official orbit solution. That revision makes one thing clear: this object still isn't behaving the way the models say it should. If this has your attention, feel free to subscribe, turn on alerts, and tap like anytime. For the best experience, go full screen and settle in. On paper, we should be in the dull phase by now. The comet has passed perihelion, it's outbound, the energy budget is shrinking. Logic says it ought to be slowing, calming, becoming predictable. Instead, the newest bulletin says the opposite. 3 Atlas has changed again. If you've been following this interstellar traveler with me, you know each change teaches us something unexpected. In this one may be the clearest sign yet that it's still actively evolving. It's not done. It hasn't settled.
Let me unpack what happened step by step, because it's genuinely fascinating. Roughly daily, NASA and partner observatories feed the latest measurements for 3 Atlas into an orbit solver, a sophisticated program that digests positions, times, and known forces. You tell it where the comet appeared, when it was seen, and how solar and planetary gravity should have moved it. It crunches the numbers and returns a new forecast: where it ought to be tomorrow, next week, where to point the scopes. If the model is sound, the gap between prediction and observation remains tiny and random. Those gaps are residuals, essentially the error bars. When things are behaving, residuals jitter around randomly, slightly ahead, slightly behind, a hair left or right, and average out. Today, they didn't.
When the newest positions were ingested, actual detections from the last 24 hours, they didn't scatter around the old fit, they leaned. Every fresh point fell to the same side, as if the comet had drifted across its track since the prior update. First clue something is different. The change is literally burned into the new orbit. The numbers themselves announce that today isn't yesterday. To drive the residuals back down, to make the model match reality, the team adjusted the non-gravitational parameters. That's the term for tiny rocket pushes from gas and dust jets. Comets aren't inert rocks, they vent. Material streaming one way nudges the nucleus the other way. Action and reaction. Yesterday's solution assumed a particular magnitude and direction for that thrust. Today's needs another. The revised fit says 3I Atlas now feels a slightly stronger lateral acceleration than before. Not catastrophic, not a sudden earthward swerve, but real, measurable, significant. The self-push has shifted. While the dynamics team did that forensic math, the imaging crew ran their own before and after, and from a totally different angle, they saw the same story. They stacked last night's deep exposures, hours of data for maximum signal, and did the same with today's, using identical instruments, filters, and tracking. Then they blinked the stacks. Yesterday, today, hunting for changes. The big picture looks familiar. Bright inner coma hugging the nucleus, a long tail stretching anti-solar, structure within structure. But right around the nucleus, the narrative changes. The bright core is no longer seated neatly in the center of its glow. Yesterday, the inner coma looked slightly flattened, an oval, with the core nestled on its central ridge. The brightness peak was where you'd expect. In today's stack, that ridge thickens on one side and thins on the other, and the peak slides toward the thick side. It's as if the inner coma was tugged off-center. The coma hasn't simply brightened or dimmed overall, it's redistributed. Material now favors one side more than the other. And there's something else. A faint secondary streamer appears at a different angle from the main tail. It's subtle to the eye, but with contrast enhancement, it's unmistakable. A new filament feeding space from a region that was quiet or weak before. Now we've got 2 independent hints pointing to the same conclusion. The math says there's a fresh sideways push. The force budget changed, so the orbit solution had to. The images show a lopsided inner coma and what looks like a new or strengthened jet. Different teams, different tools, same message. And then comes the light curve, the third piece. As usual, Teams tracked brightness over the rotation. Spinning bodies show modulation, as different surface areas and active zones rotate into view. If one sector vents more, you see a brightness crest when it faces us and a trough when it turns away. Yesterday's light curve had a repeating pattern, matched to a slightly accelerated spin period they've been monitoring. One main peak, one smaller bump, messy but familiar, typical of a comet with one dominant active patch and a minor one. Today, folding the new flux over the same period no longer aligns. The main crest shifts in phase, arriving a bit early or late, and the smaller bump grows until it nearly matches the main. Now it looks like two comparable peaks per rotation, rather than one big, one small. That's what happens when a second active region either turns on or ramps up to rival the first, i.e., a new vent opens and begins contributing regularly. Two strong sources yield two strong peaks as each rotates into view. Put it all together. The orbit was updated because the comet slid slightly sideways from where it should be. The inner coma now shows a thickened side and a new streamer that wasn't present or was far weaker yesterday. The rotational signature now reflects two strong emitters instead of one dominant in 1 week. That's the quiet shift NASA picked up. Not a giant outburst, no dramatic splitting or tenfold flare. A subtle reconfiguration. The comet has updated itself, and multiple independent lines of evidence are catching the change. Inside 3 Atlas, heat from its solar dive is still diffusing inward. As deeper layers warm, new fractures open, old vents widen or clog, and gas carves fresh channels. The active map shifts, which areas vent and how strongly. From our vantage point, that yields a shifted inner coma peak, a new streamer feeding the tail, a changed thrust vector in the orbit fit, and a double-peaked light curve. In short, the plumbing reconfigured. This isn't just imagery, it's mechanics. Two strong, offset active regions impart changing torques as the body spins, tweaking rotation rate and tilting the spin axis. That alters what gets heated next, which reshapes activity again, a feedback loop. Stress accumulates in a fragile nucleus already battered by its inner system pass. Two paths lie ahead. If activity stabilizes with two dominant vents, we may see a modest spin-up, perhaps some precession, in a gradual fade as volatiles deplete. If changes keep coming, new vents, swiveling thrust, drifting spin, then we're watching a nucleus constantly rebalancing under load. History shows there's a limit. Repeated updates and rising stress can end in fragmentation or splitting, though some comets survive. NASA's language stays careful. Updated non-gravitational parameters, evolving inner coma morphology, changing activity distribution. But the translation is simple. 3 Atlas changed again, and the model and images had to be revised. Why it matters? This object didn't form here. Each adjustment is a live probe of interstellar composition and structure, and a reminder that just when it looks predictable, it isn't. From here, it could either settle into a steady, fading state, or throw another curve, a new jet, a shifted thrust, a fresh orbital tweak. Each self-update raises the same question. How many reconfigurations can it endure before something gives? We don't know. We're watching it unfold in real time.